So to begin, my name is Katie Bezak. I'm an Assistant Director in the Office of Graduate Enrollment Services at RIT, and I work primarily with the applicants to the College of Engineering. So as you review your options for engineering at RIT, as you start the application process, you and I will definitely be in touch, and we'll be working together to help you complete your application and get a decision on that application for your engineering program. I also have included here the faculty who are joining us here today. Each of them will have an opportunity to speak with you and talk a little bit about their programs. And I also wanted to take a second to introduce my two students who are here today, Mudit and Ronak, who will be answering any questions that you have about the program. I'm going to ask them just to introduce themselves and talk a little bit about the program they're in and some of the research they're doing. So Mudit, if you wouldn't mind.
So good morning and good evening, good afternoon to the specific time zone people. I'm Mudit. I'm doing graduate course here. I'm into electrical engineering. I'm doing electromagnetics to be specific, and it's fun. Yeah.
Hi, I'm Ronak Singh, and I'm a second year PhD student. I came here at RIT as a master's student, and my aim is to get excellent education to achieve my passion as electrical engineering. And RIT is one of the best private institutes to offer really excellent education in electrical engineering. And I'm right now working as a research assistant in electromagnetics lab, and I'm working on designing antennas for multi-chip systems.
Okay, great. Well, thank you both for being here. And again, Mudit and Ronak can answer a lot of questions about student life, about research, about the course load. So please feel free to chime in and ask any questions that you have to them. But wanted to share some information in general about RIT. If you're just starting your search process and considering us to pursue your graduate studies. RIT is a private university. We're founded in 1829, and we're the 10th largest private university in the United States. We have almost 19,000 students. About 3,200 of those students are graduate students. They're enrolled in our over 100 graduate programs. So we have master's and PhD programs. And we also have 110 countries represented at RIT. So overall, our international student enrollment is about 2,600, and we have 118,000 alumni all around the world. We're located in Rochester, New York, so you may or may not be familiar with Rochester. We're the third largest city in New York State, and we are in Western New York. So a lot of times when I'm traveling and speaking with students, we get confused with New York City. We're actually not near New York City. We are in the Western New York area. It's about an hour flight from New York City, a short flight to Toronto. We're also located about an hour drive from Buffalo and Niagara Falls. It's a great place to live, and there's a lot of big cities that are easily accessible through different modes of transportation. RIT is also the leading city in the U.S. for innovation and invention. So we have a lot of opportunities for interning and co-oping right here in Rochester, which is a great opportunity for our students. At RIT, we have an incredibly diverse student body, but we're also very diverse in our program offerings to our graduate students. So as you can see on the slide, we have 9 colleges at RIT. Obviously today we're focusing on the Kate Gleason College of Engineering, but we also offer some amazing programs in fine arts, in business. We have the #2 program in game design and development in the U.S., the #2 program for industrial design, and we also have a number of programs in computing and imaging arts and sciences. So when you're a student at RIT, you have the opportunity to take courses in other programs and work alongside students on different interdisciplinary research projects, which is really neat. There's a lot of cool things happening at RIT. So our College of Engineering is called the Kate Gleason College of Engineering. It's named after Kate Gleason, and she was one of the first women engineers in the United States. And in 1884, she was the first woman engineer to enroll in the mechanical arts program at Cornell University. So we're incredibly proud of that namesake. A list of all of our engineering program options. We have many programs that range from Masters of Engineering programs in mechanical engineering to MS programs and PhD programs in sustainable engineering, computer engineering. You're going to hear today from our industrial engineering graduate program chair. So there are a lot of options, and again, all of our programs are interdisciplinary. So there is some overlap between these different degree programs, and we're going to talk about those similarities and differences today. So a little bit about our graduate student experience. We understand that choosing a graduate school is an incredibly big decision. It's a time commitment, it's a financial commitment, but we truly believe that the RIT student experience is unique and offers a really high return on investment. At RIT, we have faculty who are fully accessible to graduate students. They often have most often have the top degree in their field, and they're working professionals. So they're bringing that real-world knowledge to you in the classroom. All of our students are also hands-on learners, and they're able to apply what they're learning in the classroom to the work that they do in their internships, in their co-op positions, and in the labs that we have on campus. And RIT is incredibly lucky to have over 50 research centers right on campus, and we'll definitely be able to talk in detail about those and how they relate to each department throughout the webinar. We also focus on innovation, collaboration, and we're very career-focused. RIT has one of the oldest and largest cooperative education programs in the country, so many of our graduate students take advantage of that and will complete at least one co-op position throughout their graduate experience. Muda and Ronak, have you co-opted?
Well, I didn't co-op, but I have friends, and I have my lab mates who have co-opted here in Syracuse and all around US. So there are a lot of opportunities for co-op, as an RIT student, and professors also they also suggest you options, and they have also industry relationships which help you get a better co-op.
Hey, that's a good point. All of our faculty are connected in the industry, so they help students find internships and co-op positions and full-time jobs once students graduate. The co-op experience, if you're not familiar with it, is similar to an internship, but it's actually a full-time, fully paid work experience. So it's a unique opportunity for students to gain real-world experience before they graduate, and it often leads to full-time jobs. Actually, over the past 4 years, we've had over 3,700 international students complete co-ops in the U.S. And the most popular locations for those co-op positions are New York, Massachusetts, and California. So our students really are all over the United States doing work that's related to their degrees. All right, and because of all of these factors, we have an extremely high placement rate after graduation, and we're very proud of this. These numbers are from our most recent batch of data, which is the class of 2016, and this is information coming from the Office of Career Services 6 months after graduation from RIT. So within 6 months, over 97% of our graduate students were employed, had either gone on to full-time study, or were pursuing alternative plans like volunteer work or military service. You can see here the median salary for our programs and the number of students who graduated from RIT in 2016. We provide a lot of support in helping our students find positions after graduation, and students definitely, I think, utilize our Career Services Office and Alumni Network to help find positions. So with that, I'm going to turn it over to Dr. Jayanti Venkataraman, who is our Graduate Program Director for Electrical Engineering, and she's going to talk a little bit about her department and the unique things that are happening there.
Thank you, Katie. Greetings from RIT and from Rochester. I am Dr. Venkataraman.
Jayanti, you're a little quiet.
Oh, is it? Now? Is it okay now?
That's much better. Thanks.
Okay, let me increase the volume. Am I better
Yes, that's better.
I'm going to be describing to you the master's program in electrical engineering. The department is electrical and microelectronic engineering. You will hear from the graduate program director of microelectronic engineering a little later. I'll be focusing on the Master of Science in Electrical Engineering, MSEE. Now here is how we've laid out our program. The degree requires 30 credit hours of study, and it is split into 3 kinds of options. There is a graduate seminar for everyone, whichever option you take, and that introduces you to the program, and we have invited speakers who tell you about current research going on in that area, and we also have campus speakers who will tell you about the resources available.
Jayanti, I'm sorry to interrupt you. There's just a lot of background noise right now. I'm not sure what the sound is, but
I'm not sure why. Better, I lowered it a little bit. Is that better, Katie?
It seems to be a little better. Keep going. I mean, your voice is coming through. There's just a little bit of background noise that's coming through on the mic as well.
Again, to go over these options, there are 30 credit hours. You can choose one of the 3 options. You can do all the 30 credit hours as coursework and take a comprehensive exam at the end of it. That's the comprehensive exam option. The next is graduate paper option, where you do 9 courses and a project under the supervision of a faculty. And then the last option is the thesis option, where it is, I'll describe it a little later, it's more your own contribution to that area of research, and you take 8 courses. Now, electrical engineering is very diverse, and it encompasses several different specialty areas within it, and you can see the listing of the 8 focus areas that we offer, which primarily covers everything that you have in electrical engineering. We have strong faculty in each area, and we have strong courses in each area. And you can read the list yourself. And to describe the coursework that takes place, you have to choose courses which are 600 level and higher, which is coded as graduate courses. There are some mandated courses for each of the focus areas. It depends on which area it is, 2 or 3, and these are math-based mandatory courses. After that, you take a minimum of 3 courses from your focus area. The reason for that is your project or a thesis is the culmination of coursework, and so you need a critical number, at least 3 in that area, to do some meaningful project. And the remaining courses you can take within College of Engineering or the Center of Imaging Science, which has a PhD program, or in Computer Science, which also has a PhD program. And any others, we allow a maximum of 2 courses as electives, and those you can take outside this program that I've listed above. But however, you have to get the graduate program director's approval to be able to take those electives. So this describes overall how you lay out your coursework. And by the way, everything that I'm going to be telling you now is also available in the handbook, which is on our website. So if you go into the RIT website and the EME department and look for the master's program, and you'll find 2 handbooks, one specific to electrical engineering and the other one which is an overall policies and procedures of the College of Engineering for its master's and PhD program. Now here is the chart of all the coursework. It is a little small, but I think you can read it if you're on the computer. It's on your computer screen. It lists all the courses in the various focus areas. The top 2 rows list the mandated courses. That's the math courses, engineering analysis, and advanced engineering math. And the 2 columns, one column is of course core courses, and the other 2 columns are the semesters during which these courses are offered. So the mandated courses are offered throughout the year. Now then, the listing of focus areas, and corresponding to each focus area, you have a listing of the courses being offered, and you can always choose between the courses. There are more than 3 in each area offered in a particular semester. Now the most typically students take 3 classes are international and related areas which you can, for instance, in communications, you can choose as related areas, microwaves and antennas, or integrated electronics, you can choose related areas, MEMS. So it works out really well, and it gives you a very comprehensive field of study. Now the next one is how you plan your coursework. If you choose a comprehensive exam option, you take simply 3 courses, first 3 semesters, and at the end of the third semester, you take the prompt exam, and then you're left with only one more course that you could have even fitted in as 4 courses in one of the semesters, or just do the 4th course the last semester. Now, graduate paper option, you take 3, 3, and 3 the first 3 semesters and start graduate work without registering but under the supervision of a faculty, so you get a head start, and in the 4th semester wrap it up.
Jayanti, can I ask you to speak a little closer to the mic? You're kind of wavering in and out of the sound.
Oh, and the thesis option,
Better.
there are 3 courses. You take 3 and 3 for the first semester, and then 2 courses in the 3rd semester, and start your thesis with 3 credit hours, and the 4th semester wrap it up with the other 3 credit hours. So and we give you a lot of guidance and advice on choosing courses and how to plan your sequence. Then, of course, is the culminating experience I talked about. By New York State Education Department, we need a culminating experience in any master's program. And these are the options. The graduate project, it's conducted under the supervision of a faculty, and it depends on each faculty, their criteria, but primarily everyone requires you to do an analysis of some recent published work in that area and do a small contribution to that area as a graduate project. And the master's thesis is similar. You conduct under the supervision of a faculty, and here you do some original research work that is publishable at least in a conference. And we have pretty good success with students even doing journal papers through their master's theses. And then the final one is the comprehensive exam option, where there are 2 parts to the exam, where one part is on the mandated courses and the other for the student's focus area. This describes the coursework. Now, the internships and graduate co-op that these 2 students, Mudit and Ronak, talked about, that is something we permit, and we have a large range of companies that these students get jobs at for just an internship. So we permit it after 2 semesters of coursework, and approved by the faculty advisor of the graduate thesis and the graduate program director. And we allow a maximum, according to INS, the Immigration Services, we allow a maximum of 1 year of internship. Typically, students do 1 semester plus a summer for their internship. And this gives them some experience working in a company. It also enhances their resume to be able to get full-time jobs. There are a variety of industries which have hired our students. Like in the New York State area, there are a lot of companies like Katie talked about in Rochester itself. Then in Syracuse, there are some companies which one of my students will talk about, Anarin, SRC, and there is Lockheed. Some parts of Lockheed do take in students on an F visa, and they don't require citizenship. And then there's Micron, Microchip in the country, and Global Foundries for the MEMS those specializing in MEMS, and then there's Intel. All these take in our students, so it's really a good experience. And finally, the merit scholarships and research assistantships. The first year, whatever has been given at admission would be the merit scholarship. In the second year, we continue that, and the percentage would be based on your CGPA. And you have to be in good academic standing, and after the grades are posted in June and January, we make the allocation. Now, teaching assistantships are available. They're very limited and very competitive. Usually after 1 semester, you can try for that. Ronak, for instance, has been my TA for several semesters now, and he's also doing his PhD under my supervision. So he's my research assistant. And so the research assistantships come from faculty, and it's not from the department, whereas teaching assistantships are from the department. Other than that, there are several opportunities on campus for tutoring students or just manning computer labs. Or you can even work in the cafeteria. Now that is a kind of a very nice experience because you kind of fit in and you figure out what is this everything about the country, and international students, for instance, can interact with employers. So you learn a lot, even if it is working in a cafeteria, how to get along and how to do teamwork and so on. So these are the other opportunities. Now, I will primarily be the advisor throughout the program and primarily for the first semester. There is a staff coordinator here, Patty Vicari. She is very helpful and she'll take care of other needs for you, for coursework and registering your visas and so on. And all incoming students will be assigned an academic faculty advisor depending on their focus area of choice. And when students choose a research topic, their thesis advisor or graduate paper advisor assumes the role of academic advising. So this is basically what I have to say about the program. And unfortunately, my class starts in another 3 or 4 minutes, and I have to leave. And thank you, Katie, and good luck to all the students, and we hope to see you here at RIT.
Excellent. Thank you so much for joining us, Jayanti, and for all the information. Before we move on to our next department, Industrial Engineering, I thought really quickly maybe Ronak and Mudit could talk about their specialization within the electrical engineering program and how they chose that, and any research that they might be doing.
Okay, so Ronak is doing PhD. I'm a master's student, so I'll tell you some things about on the master's and graduate level. So we both are into electromagnetics, and mine is not much into research. Ronak does a lot of research. But what we are taught is very well balanced between theory and practical. The tools that we use to cope with our theories are the professional tools which are used by various industries and various big research institutions for designing and simulation. So the coursework is really nice. It's not that rigorous. A little bit of math you will find in every concentration, but that's, I guess it's required when you do your research or thesis or project, because you can do it on your own if you know the maths. So it's cumulatively a very nice coursework, and you after 1 year you'll be able to do things on your own, and there are always professors helping out for any of the doubts, maybe the fundamental or it be advanced level question that you might ask. So I can assure you from my experience that you can get cleared on everything, every specific question that you have regarding your coursework, and the rest, the electrical department faculty is very nice. They're really helpful. Ronak is doing research, so he can tell you more about the research in these areas.
Yes, so I'm admitted to a PhD in engineering program, which is one of the PhD program in Calculation College of Engineering. So before joining the PhD program, I was a master's student. So my major was electrical engineering that time, and my focus area was the same as Mudit's, electromagnetics and antennas. So the coursework, I actually focused on the thesis as informed to you by Dr. Venkatraman that there are 3 choices for the culminating experience: thesis, graduate project, and the comprehensive exam. So I chose thesis as my culminating experience because I wanted to move into research and do my PhD. So thesis was the best option. So and we have really good labs and research infrastructure, and you can work on different topics, different state-of-the-art topics. And for masters, my advisor was Dr. Venkatraman for master's thesis, and she advised me really good, and I was able to publish research papers on my topic. And now I am extending that my research, my master's research to my PhD dissertation, and this is my second year as PhD student. PhD in engineering program is directed by Dr. Edward Hensel, and he's really good advisor as a PhD in the PhD course. So I'll talk about something about PhD courses. So for PhD there is like 1 year of coursework and another year of your topic related coursework. Whatever your topic is, as my topic was antenna and antenna design, so I did antenna theory and microwave circuit design. And then after your second year, after the coursework in second year, you have to do research, intense research in your third year and fourth year, and publish more than 2 research papers to graduate as a PhD student.
Okay, great. Thank you so much for sharing, both of you. All right. With that, I'm going to turn over the mic to Dr. Rachel Silvestrini, who will give us a brief introduction to industrial and systems engineering at RIT.
Hi, can everyone hear me?
Yep, we can hear you.
Okay, sounds good. Hi, I'm Dr. Rachel Silvestrini, and as Katie introduced, I'm the grad program director and also an associate professor in the industrial and systems engineering department. I put on our slides for you both our mission and vision statements within the department. Our mission for both grad and undergraduate education is that for all of our programs, we really try and focus on integrating experiential learning and applied research with a student-centered approach. And this comes into play, I'm going to go to the next slide, in all of our programs. We have 8 faculty, tenure track, 11 lecturers or affiliated faculty, and 4 staff members. Our current interim department head is Dr. Cool. Here's a picture of Dr. Cool. Here's a couple of other faculty members. I didn't have much space on this slide, so I didn't put everyone. Dr. Dennis Cormier is an expert in rapid prototyping, also known as 3D printing. And he's the director of the Amprint Center, which I'll show you on the next slide. We also have Dr. Katie McConkey. She's an assistant professor focusing in operations research in our department. So we have a diverse group of faculty that are great as teachers and advisors and lead lots of different research projects that students can get involved with. Our graduate programs, we have 3 master's programs, 1 Master of Science and 2 Master of Engineering degrees. The Master of Science, similar to the other programs, Master of Science and Master of Engineering degrees all are 30 credit degrees, and the Master of Science has a thesis option, while the Master of Engineering degrees, both the ISE and the Engineering Management, result in a capstone project. No matter which degree you're doing, you'll be doing integrated lab activities with some of our state-of-the-art laboratory work, or lab spaces rather. And on this slide, I've shown you just a couple of the lab spaces, or a few of them that we have. The top picture, the panoramic that's the Amprint Center that Dr. Cormier is the director of. On the right-hand side, you see a little photo of the Brinkman Lab, which hosts both the Amprint Center and the Brinkman Lab hosts a number of different 3D printing machines for both plastics and metal printing. Also, we have the Toyota Production Systems Lab. Here you see the production system of skateboards, but that's not what this lab is about. It's about improving quality in the manufacturing process and learning how to improve that quality through various aspects. The final slide I have here for you provides some links to our various programs, as well as an admissions link. And thanks for joining the webinar either today or if you're listening at another time. And I'm happy to field questions through email, or if you contact Katie, she can always get in touch with me as well.
All right, perfect. Thank you so much, Rachel. I know you are going to meet with 2 students, so I appreciate you being here. And before we move on, I'll also mention too to all of our attendees, continue to send in your questions. I've been getting a lot of questions about assistantship opportunities and which departments we'll be talking about. We're going to be speaking to the microelectronic program director and the mechanical engineering, touching on computer engineering as well. And each department will talk about the assistantship opportunities available within their departments. So again, feel free to chat in your questions. And with that, I'll pass the baton to Dr. Pearson, who's our program director for microelectronic engineering at RIT.
Hello, everyone. Hopefully you can hear me. Okay. And let me just drag myself over here. Does that work, Katie?
Yes.
Okay, I can't tell whether or not I'm going out there. So I'm going to do a little bit of a mixture of some slide presentations and some live action stuff. So one thing you'll notice is I don't normally wear safety glasses when I'm doing a webinar, but we're going to be inside the RIT clean room, and so this will be a little bit more of an immersive type of segment here. I want to thank Gianthi for doing a great job of kind of describing a lot of the things that go on in electrical engineering in terms of the way things are organized. And as Rachel said, RIT is very lab-oriented, and hopefully you'll continue to see that as we go along. So let me go back to some of the slides, and we'll come back to the clean room in just a minute here. Are we back on slides, Katie?
Yes, you're back on slides.
Okay, there we go. Thank you. So RIT has a lot of options, as Katie mentioned, and many colleges have only one degree program in electrical engineering that covers a wide spectrum of disciplines. But RIT actually has 3 electrical-based MS degree programs. Electrical engineering, which Janthi talked about, computer engineering, which I believe Katie will be summarizing a little bit later, and then microelectronic engineering, which is what I'll be talking about, which is rather unique. But we all kind of fit together, and I want to give you a little bit of a flavor about what we do and how we're different, so that maybe you could pick the right program for you before you would arrive at RIT. So, what is the difference between electrical, computer, and microelectronic engineering? An electrical engineer might design a field effect transistor op-amp circuit, and I've got a schematic there of something like that. And maybe you took an electronics course and you used a textbook like Cedra and Smith or something. A computer engineer might design a digital logic circuit as part of a microprocessor. The schematics look very similar. They both involve transistors and so on. And they're trying to optimize the performance of the systems. Now, how does these two relate to one another? Well, electrical and computer engineering kind of overlap in the area of maybe analog to digital conversion. Once I've converted a signal to digital, I can manipulate it in the computer. But all of these things have to be actually fabricated. So microelectronics, nanotechnology, and microfabrication, we interface with computer engineering through maybe VLSI design, layout kind of things, which many of you maybe have already taken a course in at the undergraduate level. With electrical engineering, the interface is more on the order of transistor device physics and things of that sort. But more and more, we also interact with things like mechanical engineering in the area of microelectromechanical systems, or biomedical engineering in specialized sensors and so forth. So in microelectronic engineering, we are looking for people with a Bachelor of Science degree in engineering, and then the two pathways that we have are into either our Master of Engineering in Microelectronic Manufacturing or a pathway towards our Master of Science in Microelectronic Engineering, which is thesis-based. Notice we also have a PhD in microsystems. Some students do continue on here, but after that, these people will go directly, some people can go directly into the PhD systems program. So getting back to the idea of how this op-amp is made, it doesn't really look like that schematic. So we have to do artwork and so on for each of the various layers that we have. So what I'm going to do is show you a little bit about what we've got here. And so Katie, I'm going to switch the camera to hopefully the rear now.
There you go, Rob. We can see you.
Okay, yeah, you can see me. All right. So let me do the rear camera here now. Okay. So what I've got, I'm showing you right here, is this is the old school way of doing things. You know, on a piece of graph paper with a pencil, you sketch out the layout of what things are supposed to look like, and then you have to cut on this sheet of plastic the clear and red areas for each one of the levels that might be included in this. Well, obviously, if we're going to make a circuit now that has millions of transistors on it, we've got to use a computer and so on. So we actually now start with the computer. I'll go back to the slides now for a second here. And so, you know, the computer engineers are out there designing things as well. This is an image of an old-fashioned 4-bit microprocessor back in the days when you could actually see the individual transistors. And it does all start with the transistor. So we have to simulate how it's made, and then we fabricate it, and then we have to actually electrically test it to make sure that the transistors are working properly. And nowadays in industry, they're talking about 14 nanometer FinFETs and making billions of them on one integrated circuit. So we're involved in the simulation and design of those type of devices as well. And I'm going to go back up a page here. This CMOS test chip is what we do in microelectronic engineering, where we want to investigate lots of different things, various transistors, analog circuits, digital circuits, and so forth. So what we have is, I'll briefly show our faculty here. Dr. Fuller has got his class in our clean room right now, where we're going to be going in a second. And what he does is make some of those test chips. And he divides the class up into different teams, and each team is responsible for a different process: diffusion, lithography, wet etching, ion implantation, and so forth. So let me take you in the clean room now, where we're going to actually look at how we go from the computer design to a photomask to actually doing this photolithography process. And we'll be seeing some tools. This is what we call a wafer stepper, which is this is a $50 million camera. We have about a $5 million camera, which I'll show you in just a second. So let me switch back over to the camera again, if I can. All right, there we go. Thank you, Josh. Yeah. All right, so now we're entering the clean room. Got people working on different pieces of equipment over here. This is where we do our metal deposition and plasma etching. As we go down the hallway here, you'll see that we now have the yellow lights. That's because we end up, hi Nicole, we end up working with material that is UV sensitive. So this is our safe light situation. Again, this is our lithography tool for doing the patterning. We can do down to about 300 nanometers, and we've got a couple of classes working in here on the microfabrication. Going to continue down the hallway a little bit further here. This is our ion implanter. Very unique. Not too many universities have a working implanter, and it's very manual. So you get to see, this is one of the control panels for the vacuum system part of it, and this is the part that controls the beam line. So this will do about 200,000 volts, and it can ion implant boron and phosphorus into our silicon wafers. Hey, Matt. Next stop is going to be our diffusion furnaces. So right here is where we will either oxidize our silicon wafers, and you can see right there is a paddle that is going into our furnace. Right now the furnace is cold. Normally it would be glowing orange hot, and it would be at about 1,000 degrees centigrade. I'll switch back to some of the I think I'm back on that. Okay, so we saw the ion implanter, and we saw the furnaces. The final thing is when we're all done with the wafers, we have to go and electrically probe the devices on there to find out how they work and what the yield is, what percentage of working ones we end up having. And so I just want to end up with what kind of jobs there are for microelectronic engineers. You could be a design engineer, very similar to what would happen for a computer engineer or an electrical engineer. You could be a process engineer, which really is what I've been talking about, with a focus on doing the things in the clean room. You could be a device engineer, which is engineering the transistors. You could be a test engineer, and a test engineer, again, might be more of an electrical or computer engineering person. And then yield and manufacturing engineering. So that's basically what I have, Katie. Anybody that wants to find out more details about the exact curriculum and courses can come to our website. Thank you.
All right, that was great. Thank you so much, Rob. Really interesting tour, and cool to see all the equipment you have in your lab there.
Since this is the first time that we've done it walking around in the clean room, I'd be interested in feedback from the people that are listening as to whether or not I was loud enough or whether there was too much background noise or anything like that. So thank you for giving us any feedback.
Sure. All right. Thanks again. All right. And so now I'll pass to Dr. Michael Charlou, our Graduate Program Director for Mechanical Engineering.
Hi, everyone. Thanks for joining us on the webinar. Can everyone hear me okay?
Sound good.
Great. Thank you, Katie. So I get to finish off the programs, or sorry, there's still computer engineering, but I have a few minutes. I just wanted to go over our program and tell you what we're all about. So just at a glance, we have about 250 graduate students, which consists of some of our dual degree students, which were actually here for undergrad and then continued on into our grad program. And then we also have about 130 graduate students that already have their bachelor's degrees and come into RIT to study. To support all these students, we have 36 faculty and instructors that teach a variety of different courses, have a variety of different expertise, experience, and we have 38 educational and research labs that we do our instruction in. And as you've heard so far, every single program has really focused on this hands-on environment for learning, and that's what RIT does very well, and we continue that legacy. So why would you consider coming here for a graduate degree? Well, there's several reasons. First of all, we have cutting-edge theoretical and applied research that is performed by internationally renowned faculty. And these faculty have a variety of expertise and experience in industry and in academia. So you get a wide variety, a wide spectrum of experience. To do the applied research and to learn from faculty, we have some world-class research and educational facilities. And that allows us to enable students that come into our program to customize their studies to specific interests. And I'll get into that in a second. As you do your study, again, we have a hands-on learning environment, and we hold true to that. You also heard about co-op programs. So many of our students take advantage of our co-op network here, and that's one of the most popular options to get some real-world experience here in the U.S., and many take advantage of that, and we encourage that. Something that helps with the co-op program and getting jobs later is we have a very expansive professional and alumni network. And so our graduates coming out get very high-paying jobs, and they get the very high placement rate. So just some of the cutting-edge faculty research. I put a bunch of pictures up on the screen here. You can see we have research everywhere from energy to biomedical research to gears and drivetrains to doing computational fluid dynamics in a variety of systems. We have automotive, we have tribology, we have cooling systems for electronics, we have manipulating droplets, we have nanoparticle research, and there's a whole host of different things. Oh, and I forgot the one in the corner here, robotics also. So we do a lot of robotics as well. So there's a variety of different things that you can get involved in. In terms of focus areas, we have several. I won't go over all of them, but you can see up on your screen there's a variety of different types of focus areas, right? From very hardcore mechanical engineering type concepts to more broad business-based or industrial type practical focus areas. We also have a custom one. So if none of these work for you, you can make your own. And that's one of the main things about our program too. It's very customizable. We have 2 degree options. We have a non-thesis option, which is what we call Master of Engineering, and then we have a thesis option, which is Master of Science. Both degrees, one focuses, the focus of Master of Engineering are for people who are really not really interested maybe in going to grad school. They want to gain more expertise in mechanical engineering and apply that in an industrial setting. Masters of Science are for those that are interested in going on to further graduate studies. But one important thing is that neither degree precludes you from going into industry or going on to graduate studies. Very brief, in terms of the Master of Engineering degree, again, it's a non-thesis course-only master's degree. You take some core courses in a focus area of your choice. You take some electives, and then to finish off the degree, you do a capstone. And I'll get into the different options for capstones there. We encourage students to study outside of the ME department, although you can only take 3 outside of the mechanical engineering department. But that could be business, that could be industrial systems, it could be computer engineering. It doesn't really matter. Actually, that adds to your experience. And again, the co-op program is an option. We highly encourage students to take advantage of our co-op program while they're doing their study. In terms of capstone, the 2 that will be of interest to you are the project with paper and graduate internship. So you can do kind of a 1-course focused project with an advisor, and that is your culminating capstone project. Or you could take an internship. If you find an internship with a company, you can use that as your capstone as well. And both with graduate internship and co-op, you need to be here at RIT for 2 semesters, which is equivalent to 18 credits before you can go out and work in industry. Moving to the Master of Science degree. Again, this is a thesis-based master's degree. You take core courses, again, some core.
Michael, it sounds like your voice just cut out. I'm not sure if something happened on your end with the microphone, but we can't currently hear you. Michael, I don't know if you can hear me, but we cannot hear you right now. I can't tell if it's just me who can't hear Michael. Robin, if you're still there, can you hear? Okay, so we lost Michael a little bit. I know he's still here and he's moving his slides, but I can finish and talk a little bit for him about the conclusion of his presentation. Mechanical engineering does provide scholarships and assistantships to accepted students. All students who are admitted to the mechanical engineering program are notified at the time of admission if they've received an award. Typically, scholarships range from about 20 to 40% of the cost of tuition for graduate students. And students, typically after they've completed a year of study in the program, are eligible for graduate assistantships and teaching assistantships when they're working alongside faculty to teach undergraduate courses or conduct some research. I've received a couple questions that are being chatted in about whether it's possible to become a PhD student after completing a master's degree. And the answer to that is that it's absolutely possible. And I think I will ask Raunak, since he's here. Raunak is one of our graduate students. He began as an MS student. He is now in the PhD program, I believe he said in his second year. Yeah. And maybe you can talk a little bit about the transition from master's to PhD and what motivated you to continue on at RIT. Let me pass the mic to you.
So I came here like 4 years ago, I think 3-4 years ago, and I started my master's. So that time I want to focus on the research field, and in masters we have a lot of courses, and at the end you start your research, and that's how I after doing my master's thesis, I applied for the PhD program. So I think the deadline for the application is in January, and you can if you are here at RIT, so you can go and talk to Dr. Hensel, and you can attend some PhD in engineering seminars, which will tell you more about the PhD program in detail. And after you are working in your like second year in masters, you can apply for PhD, and then you'll get your acceptance in March, I think. Around March, you'll get to know like you are admitted or not based on your academic performance and your research skills. Yeah, that's pretty much it. And after you get admission, so you can join the PhD program just after you have completed your master's program, like maybe in August. You can start in fall, and yeah, then you have to like the only thing is like you have to complete your master's program before joining the PhD program. So that's a mandatory thing. So you have to complete your thesis work before fall. So maybe in spring, around spring. And that's it.
Okay, excellent. So again, it definitely is possible to come to RIT for a master's program and then decide to stay on for a PhD and continue your research and your work alongside faculty members. Okay, I got a question about assistantships and scholarships within the industrial engineering program and how to apply for scholarships. I'm going to talk about that in a couple of minutes, so I'll save that question for a future slide. First, I'm going to talk briefly about the computer engineering program. RIT does have an MS, Master of Science in Computer Engineering, and although unfortunately our director of the program couldn't be here with us today, she did send me some slides, and so I'll review her information briefly with you. And then we'll talk about scholarship opportunities and how to continue your application to RIT for the spring or for the fall semester. So a little bit about computer engineering at RIT. RIT is incredibly proud to be ranked as one of the top computer science and engineering schools in the country. Again, we're one of the largest private universities, but we're also one of the top producers of graduates in the STEM fields, so science, technology, engineering, math. We're ranked 14th in the Northeast, 36th in the country for computer science and engineering. And our computer engineering program was established in 1975. We have 7 research labs, 7 teaching labs. So again, you'll definitely have the opportunity in the computer engineering program to have hands-on experience, conduct research, work alongside faculty members. Let's see. All right. So there are scholarships and research opportunities available within computer engineering. Tuition scholarships are awarded to first-year students. Again, you're notified at the time of acceptance whether or not you've received a scholarship award. And for computer engineering, these awards can range anywhere from about 10 to 50% of the cost of tuition. Of course, the higher levels of award are reserved for our most talented students. And there are research opportunities, research assistantship positions available in different labs under faculty guidance. And second-year students are also eligible for teaching assistantships. This slide demonstrates the requirements for the computer engineering program. The program is a total of 30 credits, and you can see some of the core requirements for the program. There are a number of electives that students are allowed to select from, and the program offers a number of different concentrations that you can choose from. Like mechanical engineering, you have the option of completing a thesis option or a project option, and so there's a little bit of information on the slide about that as well. For our graduate students, the co-op opportunity is not a requirement, although we do encourage our students to take advantage of the opportunity to intern or complete a co-op assignment after their first year of academics at RIT. And these are just a couple examples of the different companies that hire computer engineering students at RIT. These companies also hire students from many other departments. And across the board at RIT, I would say that Amazon, Microsoft, Google, Apple, Intel, those are some of the top companies that hire our students for co-ops and for internships and for full-time jobs after graduation. One thing I did want to mention during this webinar is that RIT, being extremely career-focused as we are, we host 2 annual career fairs. One is in the fall. It actually just occurred last week, right, last Wednesday, and one is in the spring. And the co-op or the career fair this fall brought in 258 companies to RIT. The career fair was held over 2 days. The first day was an opportunity for the companies to set up booths and talk to students who are interested about the opportunities available in their companies. And the second day of the event was interviews. So students could be hired on the spot for different positions for the spring semester, for next summer, or they could just gather information so that when they're ready to look for a full-time job or for an internship, they had the information that they needed. I'm going to ask Muda and Ronak again, because they're here, just to talk about their experience at the career fair and maybe some of the interactions they've had with some of these companies or that their colleagues have had with internships and co-ops.
So for the career fair, I would say it's huge. Here at RIT, we have almost 250 companies coming in, and you'll see a lot of opportunities. But apart from that, the best thing is, even if you join in the fall or the spring, the career fair is just next month when you join in. So I have got friends who got admitted and joined RIT, and in the first semester itself, they got a co-op for the next semester, so they completed one semester and went for a co-op. So that's a really nice opportunity if you plan it very well. And there's plenty of opportunities you can get at the career fair. There are companies across all domain, from research to lab work to manufacturing. So it's a nice exposure. Even if you don't get a co-op, you really get to know how to approach for a job or a co-op or an internship, because in every country it's a different trend. So you get a really nice idea of how these things work over here. Ronak can tell you more about them.
Yeah, so like job hunting, it's really, like a very tough job to do, and the most important thing for job hunting is like to make networks, like to know people, to know HRs of the companies, and basically doing networking. That's the most important thing to which will get you a job. And RIT, because of the career fair, it allows you to interact with people from different various companies, and it will also allow you to know how to interact with them. That's really important. Ask them important questions about their companies, and to show them your skills, to show them your resume, and all these things matter in job hunting. And for co-op opportunity, as we told you, there is a lot of co-op opportunity, and
Okay, awesome. Thank you both for sharing that. I wanted to thank all of our program directors for sharing their expertise today. Again, our computer engineering program director couldn't be here, but you can email Tarisha anytime. She's happy to answer your questions. But it was really helpful to have our faculty share some insight about their programs. Before we finish up today, I'm going to talk a little bit about RIT admissions requirements in general. So again, as you look at your different graduate school options and think about where you want to apply and where you'd ultimately like to end up for your graduate studies, hopefully some of this information will be helpful to you and help expedite the application process when you're ready to begin that. So at RIT, our entire application process can be completed online on our website, and the requirements are pretty standard. We want to make the process as simple for you as possible. So all applicants are required to submit copies of their undergraduate transcript, and those transcripts can be, they can be electronic. We don't need your original copies, but they need to be scanned copies of the original documents and a degree certificate. We require a statement of purpose. There's typically not a specific topic that you need to write to. It's a general statement of purpose about 1 to 2 pages long. A chance for you to talk about your experience and your career goals. We also require a resume, and international students are required to submit the results of a TOEFL exam or IELTS exam. Every program has some variation of these requirements, so I definitely recommend you look on our website, look at the individual program that you want to apply to, and see what's required so that you know and have time to prepare. But other requirements, depending on your program, could include letters of recommendation. Typically, we require 2, but there can be additional requirements for certain programs. Some programs, like our MFA programs or our game design program, will require a portfolio. And then you may be required to submit additional test scores, such as the GRE or the GMAT exam. Again, everything can be submitted online and electronically. And RIT, in general, for our graduate programs, admits students on a rolling basis. So what this means is that there is no firm deadline, but we will review your application and send it to the admissions committee as soon as it's complete. So once your application is sent to us, we have all of your supporting documents, then we will forward it to the admissions committee for review, and you can expect a decision within 4 to 6 weeks. So again, I encourage you to look at our website, make sure that there aren't any priority deadlines or deadlines for your individual department. Like I said, in general, we do accept applications on a rolling basis, but there are a couple programs that will look at applications by a priority deadline for first come, first served scholarships and for competitive admission. All right, so we have a number of different financial aid and scholarship awards available. In 2016-2017, we provided almost $24 million in scholarships and graduate tuition remission to about 2,600 graduate students. So the most common type of award would be a tuition scholarship. This is a scholarship that does not require any work. It's completely based upon merit. So your entire application is reviewed. We look at your GPA, your test scores, your work experience, letters of recommendation, basically everything you've submitted to us to make a decision about your potential to succeed in the graduate program. There's no separate application to apply for scholarships or for assistantships, but when you complete the application, you're automatically considered for those awards. So all of the programs do have scholarships available, and they're awarded to most competitive students. And we'll notify you when you receive your acceptance letter of the scholarship award that you've received. We also have graduate assistantships available. These vary by department. Many of our departments will award these positions to second-year students, but there are definitely MS programs that award assistantships to first-year students as well, based upon your previous research experience or work experience. In addition to those financial aid awards, we do compile a list of outside sources of scholarship that can be helpful to you when you're looking at ways to supplement your income or to help pay for the first year of tuition at RIT. And we have many, many opportunities to work on campus. So overall, we have over 9,000 on-campus jobs. International students can work up to 20 hours a week during the semester. You can work 40 hours during break, so on winter break and during the summer. And the jobs range from working in the campus libraries or the gym to working in food service. I know, Muda, you have worked in multiple positions on campus.
Yeah.
Ronak, I'm not sure if you've worked on campus. Did you have a hard time finding a position, or maybe you can talk about how that balanced into your campus schedule?
Okay, so what I really like about RIT is most of the campus is run by students, essentially, not in the administrative positions, but if you look at the lower level or the technical level, it's all students who are in the office desks and administration office technical ends. So there are a lot of opportunities on campus working. So I have worked in dining services. I am a TA for University Physics, and I work here at the graduate admissions office also. So it's up to you how you approach and look for jobs, but I won't say that you cannot find on-campus employment here at RIT. It's a sure thing if you look for it. So that's another way to support you financially so that you become independent, pay your rents, pay your credit card bills. So it's nice and it adds up to your personality. And it's fun working here on campus. You get to know lovely people, and it's a very collaborative campus. You get to see people from almost all around the world. We have a large crowd of international students, so you get to work with them, know culture of their own country. So it's an all-round development of your personality, I would say. Rona can tell you about some research-oriented jobs. on campus available?
I have also worked in food services in my first year, and you have to make a balance, in your work and your studies, because you came here for study, so you have to focus on the study, plus you have to work sufficient number of hours to financially support yourself. And on campus there are a lot of opportunities, so I did find one in food services. And after my first year, I because of my academic excellence, I got a teaching assistant position, and I was working in the lab as teaching assistant, assisting undergraduate students. And then I'm still a TA and a grader also, plus I'm a research assistant, doing research for my PhD.
Okay.
Yeah. Thank you.
Great. So I think that's a good point. Working on campus is a great way to be a part of the campus community, get to know people. The hourly rate does vary based upon the position, but it's a nice way to make some supplemental income and have some spending money while you're on campus. Okay. So in summary, RIT is a great place to be. I will speak again to the slide that I showed earlier on in this presentation about our return on investment and our placement rates. And because we're career focused, because we're specialized and we give you hands-on experience in the classroom, we give you access to faculty who are real-world professionals working in the industry, teaching you the most relevant and state-of-the-art techniques and specialties. We're really proud of our high placement rate, and as I said before, over 97% of our graduate students who graduated in 2016 found jobs or went on to further graduate study within 6 months of graduation. And so we try to be as transparent about this as possible, because we know you're making a very big decision when you're choosing a graduate program. And if you look on our career services website, you'll find information that's broken down by program. So again, the information I gave you was general as far as placement rate and average salary. But if you want more specific information, you can break that down by discipline and read more about what kind of companies and jobs our students have gone on to, as well as what the average salary is for recent graduates. Finally, RIT is one of the most technical institutes in the country. Every program is technologically based, and its technology is infused into every program. So next up, as you continue your graduate research, I would encourage you to look at our website. It's rit.edu/grad. There you'll find a specific page of information about each graduate program, and there's information about the admissions requirements, about the curriculum, again about job outcomes, and faculty contacts. So you're welcome to reach out to our program directors if you have more specific questions. You can always connect with us through email, through phone, or you can log on to our website and chat with us. We do have a live chat feature that allows you to speak with an admissions counselor if you have questions. And I also encourage you to connect with us on social media. We're on Facebook, we're on Twitter, and it's a great way to meet other students, ask questions to them, and just get information about RIT events and research and things that are happening in student life at RIT. And when you're ready to apply, you can create a personalized portal and application on our website that will allow you to begin the application and work through it at your own pace. So with that, I will leave you with a number of resources. I will stay on this webinar for a couple more minutes, so if you have any other questions, feel free to chat those in. And again, thank you so much for being here today. I hope that this information was helpful to you and gave you some details and insight into what makes each of our engineering programs at RIT unique. And hopefully you have information that will help you decide what the best fit is for you. I want to thank our faculty and program directors again, as well as Muda and Ronak for joining us today and for their valuable insights. So we look forward to working with you throughout the application process, and have a wonderful day or night, depending on where you're tuning in from. Thanks again.
Thank you, everyone.
Bye.
Bye.